The degree of the amines. Well, in order to answer that question, we need to first be able to find them, right? So here's an amine right there. What degree is that amine? That's a tertiary. Okay, because there's 3 carbons directly attached to it. Nice. Do we have any other amines? Yes, this one right here. What type of amine is that? That's a primary amine because there's only 1 carbon. So when we take a look at the alcohols, we have this one right here. What's that alcohol? Okay. But what verbiage would we use? Primary. Nice. And how do we know that? Because we find the carbon that's directly attached to the oxygen and ask how many carbons are attached to that. And we see that there's only 1. So based off of that explanation, what is the degree of this alcohol in the corner? Okay, so did I hear tertiary and secondary? I just heard secondary? Okay, good. That's a secondary because that's the carbon that's directly attached to the oxygen. How many are attached to that? 1, 2. Does that make sense? Okay, where's the quaternary carbon? Right there. There's the quaternary carbon. What functional groups are present? Well, we already found the alcohols and the amines. What else do we have here? Where's a ketone? Okay, there's a ketone. There's an ether there. We have a benzene. We could call it a benzene ring. What about this guy? There's an alkene right there. I think that counts for that. How many hydrogens? I don't know. I'll count those later. You guys can count them. And if you want some validation, post it in the discussion forum. Okay? But count your hydrogens. Let's see, how many lone pairs are there on all the hetero atoms? That should be really quick based off of the assignment that we've already done today. So we see that there's 2 there, 1 there, 2 there, 2, 2. Like that. Okay? Heteroatoms. That brings up a good point. Heteroatoms, they're just things that are not carbon or hydrogen, right? So when you have an oxygen atom, people will make this mistake. They'll be like, oh, that's an ether, but we have implied hydrogens on the oxygen atom. Hydrogens are never implied on heteroatoms. They have to be drawn out explicitly. Okay? The only things that are implied are carbons. Okay? Let's see, what orbitals are used to form this bond right here? Okay? So we have to use valence bond theory. And we know that what we have here is a carbon, double bonded carbon, then we have something like that, and then we have a hydrogen here and some R right there. But I'm worried about this bond right there. What orbitals are used? Well, we have a carbon-carbon bond between the sp2 orbital and a sp2. All right, that bond right there, let's color code it. That bond we could say is this one. And that would be our sigma bond. All right, that's equals sigma. Now, where's our pi bond? Well, we have a carbon p orbital and another carbon p orbital, and that's represented right there. So we have 2 different types of orbitals that are used to make that double bond. We have p orbitals and sp2 hybridized orbitals. Okay, we went over ethene at the beginning of the semester, first week. We went over all that. Okay, so that should be a review. Do you guys have any questions other than how many hydrogens there are? Yeah.
Is the answer to the question you just answered both of those, or is it just the carbon-to-carbon sp2 sp2?
Well, in the one I was implying, I was saying this bond right there. Okay, so that's all I wanted to worry about. But could you explain what orbitals are used to form this bond right there? Hopefully you can, and you should be able to. Right? Because now if we looked at that bond, what do we have here? We have a CH3. This one's an interest, a little bit different because this carbon is sp2, that carbon is sp3. So this bond right here is between a carbon of an sp3 and a carbon of an sp2. That's the orbital overlap to form that bond. Is that a sigma bond or a pi bond? No idea? That's a sigma bond. All right? Pi bonds are the ones that are above and below the bonding axis. These are head to head. So make sure you can take a molecule like this and draw the orbitals that are doing that bonding there. Okay? So how much time do I have?
3 minutes.
3 minutes?
Yeah, something like that.
Okay, so what can we do for 3 minutes? People can leave. I could also do a pop quiz if I wanted. Okay? So, if you guys want to leave early, do it quietly. Don't make a big noise because people want to hear what's going on. Okay? We still have 3 minutes. So, if we have something like this here. Could you describe the bonding of the orbitals that are used to form this bond versus that bond? All right. I appreciate your honesty. But if you try to figure out the bonding of benzene with Valen's bond theory, you're going to get very frustrated. Okay? Because it's just not going to work out like you've envisioned. And that's why the models that we learn in chemistry, sometimes they work, sometimes they don't. And so in order to understand this, we have to use molecular orbital theory. Okay? Something that you've been introduced to, hopefully, in general chemistry too as well. And we'll talk more about MO theory later. So you guys have a good rest of your week and a good weekend.